All right, this one is absolute value from section 2.7. So first thing I always do with these is find the vertex, which for these is always the opposite of what's on the inside. It's a positive 2, so making a negative. And then whatever number is on the outside of the absolute values is your y. So that's the first thing I always find. That's the first thing I plot. Negative 2, 3. All right, from there, the negative 1/4 on the outside tells you everything else you need to know. Okay, it's going down because of the negative, so it's going to be an A shape. And it's going down 1 and then to the right 4 and then down 1 to the left 4. Down 1, over 1, 2, 3, 4. And then same thing on the other side of the vertex. Down 1, over 1, 2, 3, 4. Make these 2 straight lines. Okay, they're not curved. They are 2 lines meeting at a vertex. To make it look as neat as possible. And for these, the domain is always all real. So maybe put a little star next to that in your notes. That's not ever going to be any different. The range depends on your vertex. And since my vertex is at the y value 3, my range will come from that y value of 3. That's from right here. And it's everything below. The graph goes down from that vertex. So it's everything less than or equal to 3. The axis of symmetry is always a vertical line, and it comes from the x value of my vertex. So it's x equals negative 2. All right, the first line, I would choose not to solve for y. I'm going to pick the 2 points. So I'm going to find the 2 intercepts by letting x be 0 and y be 0. So if x is 0, I've got negative 4, y equals negative 10. Well, if I solve that, you're going to get a fraction. But negative 4 divided into negative 10, that reduces to positive 5/2. And then if I let y be 0, I get x equals negative 10, which is pretty easy. It's just negative 10. Okay. So if I plot those 2 points, negative 10, 0 is right here. 0 and 5/2, that's 5/2 is the same thing as 2.5. So it's about right there. Just do the best you can. And then you connect your line using a solid line because of the equal to mark. Okay, and I'll do the shading later, but this is a less than. But because this y is negative, you have to really think about this sign being flipped. Because anytime you divide by a negative, you flip the sign. So this really, if you want to put a little note off the side, really should be a greater than. Okay, so it's going to be above this line. The other one is an absolute value graph. The vertex for this is the opposite of the inside, which is 1. And then whatever is on the outside, which in this case is 0. So my vertex is 1, 0. And my 3 out here tells me, in a way, my slope. It's up 3 over 1 to the right, up 3 over 1 to the left. It's also a solid line connecting those 3 points. Okay? So we already know it's above the straight line, but it is less than, and we may have already done this question before, it's less than my absolute value. So less than the absolute value is everything kind of below the vertex and surrounding it. So it's everything, kind of on the outside of the V shape, and then everything above the line. The common shaded area is this portion and this portion. Okay, if you use a pencil, you can probably do it better. Shade everything outside the V, shade everything above the line, and then find where your shadings meet. Okay, and you'll see that it's there. Okay. All right, for this one, the first thing you want to do is find the x value of the vertex using this formula. So my b is 8. The opposite of that is the negative b part. It's negative 8 over 2 times a, which is negative 4. When you reduce that down, you get a positive 1. That's the only thing you have to do by hand. The rest of it, put it in your calculator. Give me a second to type this in. Negative 4x squared plus 8x plus 2. Go to your table of values and find this 1 right here and put it right in the middle of your table of values. I'm going to scroll up a little bit until that 1 is right in the middle. And I'm just going to plot all the points that I can. So I can do, of course, the 1, 6, which is my vertex. Then I can do the points 0, 2, and 2, 2. So 0, 2, and 2, 2. And then I can also do -1, -10, and 3, -10. And when you draw these, remember this is a curve. It is not a V or an A shape like absolute values. It is a curve, although it's kind of tough to do the steep that graph is. And then make a little note somewhere that the domain for these are always all real. That's not going to change. Your range, just like your absolute value graph, depends on this vertex. This vertex is located at a y value of 6. So it's all values less than, because it's below that graph, less than or equal to 6. And your axis of symmetry is x equals that 1 value. It's whatever splits that graph directly in half. All right, for this one, this is in vertex form. So the first thing you want to do is find the vertex, which is, now pay attention, is the opposite of what's on the inside, and then whatever's on the outside, which is -3. That's the first thing you find. Okay, -1, -3. Everything else is done in the calculator, so I've already got this typed in. Go to your table of values and just start plotting points. And make sure you put that -1, -3 in the middle and plot whatever you can around it. I can do -2, -1, and 0, -1. I can do 1, 5, and -3, 5. Once you do that, connect your points using a curve. And you got your graph done. Your domain, just like all the other quadratics and all the other absolute values, is all real. Put a little star next to that, and do a star next to the last one too. I didn't do that, but go ahead and draw a star next to that last one as well. Your range depends on the vertex. The vertex y value is at -3. And because my graph is everything above that point, it's greater than or equal to -3. Your axis of symmetry splits this graph right down the middle, which is at the x value of -1. Alright, this one is in intercept form. The reason why, it tells you both intercepts. This +1 is the opposite of that, so it's a -1 intercept. This -3 is the opposite of that, which is a +3. Okay, that's 2 of the 3 points you need. Now, we know that our vertex falls somewhere in the middle of those 2 points. We just got to find out where that is. So what you could do is take your pencil or your pen or whatever and work your way in, like start at the points, go 1 unit in, another unit in, and they meet right there at the x value of 1. That's fine. I don't usually do that because if they're really far apart, or if they have, their distance apart leaves you halfway between 2 points, the easiest way to do it is take this -1, add this 3, and then divide by 2, and that gets you a 1. So your vertex is 1 something. So you can go to your table of values if you want to, or you can just plug 1 in for x. 1 plus 1 is 2. 1 minus 3 is -2. 2 times -2 is -4. Or you can go to the table of values and type this in, which is probably the easiest thing to do. And go to your table of values and look for the x value of 1. It tells you it's -4. Okay, so that is your vertex. There's your graph. Now your domain, just like all the other quadratics, is all real. So maybe put a little star next to that to indicate that's not going to change ever. Your range still depends on your vertex y value, which is -4. And since it's everything above that -4, it's greater than or equal to. Then your axis of symmetry is what splits this graph directly in half, which is at x equals 1.